Hey guys, our lesson today is talking about solutions of linear equations. So we've been solving equations, and the types we've been solving are called linear, which we'll talk about. And today we're going to focus on when they have a certain number of solutions. So our mindset message today is that math makes sense. I just want to remind you guys again that sometimes it's hard to make sense of, but math really does make sense, and every single one of you can make sense of it and can understand it and can be successful. Our learning goal for today is to tell how many solutions a linear equation has, and of course we're going to be getting more practice with equation solving using the basic moves. And so our prior knowledge here, essentially the most important prior knowledge here would be solving equations by using the basic moves like we've been doing recently. We're going to start out with an important vocab word that you should have in your own vocab list. What we call a linear equation. All the equations we've been solving so far are considered linear. And that means all the variables involved have just a power of 1. And just to remind you of this, remember this guy like right here, 3x plus 5 equals 18. You notice there is not a power here, but technically there's a power of 1 there because there is one copy of that variable. We just don't generally write it for that. Okay, so you notice all these, any variable you see only has a power of 1 on it. Okay, so this has just one variable, this has two variables, but it still counts as a linear equation. This one's weird because it has one variable, but it has this division in it. Normally we don't really love to have division, and we actually would typically use a basic move to rewrite this one. And this is dividing by p, so I'm actually going to undo that and multiply by p, but if I do it over here, I'm going to need to do it over there, right? And since this is dividing and multiplying, they cancel out. You could also think of it as 1 over 1. Then this equation turns into p minus 3 equals 8p. And we like that better, that version. There's one little thing though. If you remember that we can't divide by 0, technically speaking here, we need to just make sure we realize that p can't be 0. We'll get into that later. Don't worry too much about that. I just want you to know about examples of things that are. Now let's look at some examples of things that aren't. Well, this is not an example. It has two variables. This guy right here is linear, but this has a power of 2, so not. This right here, you may look at it and be like, well, this only has a power of 1 and a power of 1. But the square root messes things up actually a little bit because it's another situation where we might do something to both sides. In this case, we would square both sides. And you notice when we square this y, it becomes y squared. So normally, we also don't really leave roots in there when we mess with those. Kind of like here, we don't really like to leave division. Okay, so that's some reasoning to understand why this one's not linear. This one here clearly has cubed. Even though it looks like this v is just v, if we multiplied this all out, right, if we cubed it, this v would end up having cubed on it, so it's not linear. This one here kind of looks, in fact, it looks almost identical to this one, right? And all the p's just have a power of 1. But we have to be slightly careful because if we do what we did before by multiplying a p on both sides, you'll notice here that this becomes p squared, which is not linear anymore, okay? But for now, just try to kind of digest what I said. We'll come back to that stuff through this course. For now, just kind of understand that what a linear equation is it just has the variable with powers and no funny business going on. So our next fact for the day, or our most important idea for today, is that a linear equation can have 1 solution, 0 solutions, or every number as a solution. We're only focusing on linear equations that have 1 variable for now, not 2 variables or more. We saw some examples of ones that had like x and y, but for now we're focusing on just 1 variable, okay? So let's take a look at these 3 cases. You can have 1 solution. Remember, that just means the equation is true for just 1 number, right? So an example of that would be 3x plus 4 equals x plus 10. And you know, if we use the basic moves here, if I subtract x from both sides, then that leaves me with 2x plus 4 equals 10. Now, I'm actually going to leave this here for a moment because I want you to get in the habit of trying to look at an equation without working it all the way through and knowing if it has one solution or zero solutions or whatever. Okay? At this point, you know that you can backtrack this and figure it out. So all I care about is realizing, oh, yep, that one has just one solution. Now let's see if we can tell just by sight about these ones. If there are zero solutions, remember, that just means it's never true. There's no number you could plug in that will ever make it true. And if you look here, you can see that this is always out of balance. Because watch closely. The 3x and 3x perfectly balance each other. But this 4 and 10, the 10 is always heavier than the 4, right? And we can't do anything about the 3x's, because if you tried to use the basic moves and work it out, and that would be the first one, you would get 4, because these cancel out, and so do those, and it would lead to 4 equals 10. But of course, that can't be true. So you can kind of realize just by looking at the original equation that it's always out of balance, no matter what x is, because the 3x pieces are identical to each other, but the other piece is not identical. But then we have this situation. If those pieces are identical, in fact, if the whole entire thing is exactly identical on both sides, well then, no matter what number you tried to plug in for x, you'd realize it's just always true. And it should make sense. Maybe it might seem too basic to you, but it should make sense that this and that are equal always. And there's not really much work we necessarily need to do. Of course, if you ever tried to use the basic moves, every step of the way, every single step would always just be true, no matter what. So, so what I want you to do here is determine the number of solutions that each of these 4 linear equations has. But remember, in our last example, each of those equations, more or less, was like ready to know. These, you can't quite look at them immediately, maybe. So what I want you to do first is make sure that you simplify both sides of the equation. Now remember, we're not balancing yet right now. We're not applying the basic moves, just simplifying. So this left side, it can be simplified and made more simple, I guess. And you can do that for each of these a little bit, okay? So go ahead and pause for yourself right now, and then we'll come back together and look at it with each other. Okay, so I've done the simplifying already for you, and I kind of kept this bar in here because I really want to make sure you're not doing any balancing right now, because we've only simplified first. And you can certainly pause right now and double check your work real quick. But let's now move on. This one boils down to saying 10x minus 12 equals 10x plus 12. Ooh, they both have a 12, so that's a little bit tricky. But this is always out of balance because the 10x is the same, and we know that negative 12 is never equal to 12. So this one you can say it has 0 solutions. It's just never true. I guess I won't say 0 because you might think 0 is a solution. So 0 solutions. This one, when you simplify and work it out, you get 5y plus 3 equals 5y plus 3. And we know, oh, well, that means it's always true. So every number is a solution for that guy. This one here, the variable, the number with the variable is different. So kind of by nature, that is going to have just one solution. And then this one I did on purpose because they both have 3 and p plus 2. But you and I both know with the parentheses that means something different, right? Because the order is different. So this one actually is the same as saying 3p plus 6. And you can see because that has the 3p, but that other number is not the same, that it has 0 solutions. So 0 solutions. Often we also say no solution. That's appropriate as well. One last extra tidbit for today before we're done. So we are done with the main part of today's lesson, but I'm going to throw in some bonus here because this practice is going to be super helpful since we just finished learning to use the basic moves. The basic moves apply even if there's more than one variable, just to rewrite the equation into a different equivalent equation. So this is another one I want you to actually try to take a stab at yourself, and then we'll look at it together. So go ahead and pause right now. Okay, so for this one, should be pretty clear that what we did on both sides is we just subtract 10. Okay, and when I say for any of these, I mean from both sides. All right? Well, for B, a little bit different, but we subtracted 2y from both sides. From this one, interesting, they're all involving subtraction. It'll be helpful later. From this one, what do we do to both sides? We subtracted 7x, but the last one's a little trickier. It's going to help if you look back at this one because D involves 2 steps to get here from the original. And the first step is here. So what we could say is subtract 7x from both sides, and then what did we do from C to D here? Do you notice? This is 2y, but that's just y. And then this was 10, but it's 5, and that was 7, but it's half of 7. Oh, we divided everything by 2. So this one's a 2-step. We subtracted 7x, and then we divided by 2, and we got it to look like this. Now, this one's important. I'm going to put a star by it, because we say that this right here is solved for y. And being able to solve for one or the other of the variables, even though there's 2 variables. So when I say solve, be careful. In this case, it doesn't mean you've found like y equals just a number. We've just rearranged the equation so it says y equals b. Okay? So that'll do for today's lesson. So happy math, and we'll just see you next time.